All right. So, hello and welcome everyone. I hope I'm audible to all of you. Please let me know. So, welcome everyone to this channel on Pradhan Academy. So, again, I wish you all a very good evening. So, today we're going to discuss about the topic of parabola, right? So, if you have someone who is new to this particular channel and you are watching this session for the first time, then I would like to give you a brief intro about this. So, here in this particular channel, we are coming up live every evening, and we are basically discussing about some of the important chapters of maths and especially getting ready for the JEE Mains second attempt. Okay, so students who have basically covered their preparation for your class 11 part and have done their preparation for JEE Mains and the syllabus is done, I would like to welcome all of you to this particular session where we were going to discuss about the previous year problems. Okay, so as of the last session, we have already discussed about circles, and if you go to the channel, you will find out the live session that I have taken so far. Okay, so in the JEE Mains series, we started with straight lines and then we move to circles, and today it's our turn to discuss about parabola. Fine. So today we're going to discuss about the top important previous year problems on parabola, and with those questions, I'm going to teach you or show you how those questions are going to be solved up. Okay. So those questions are not very difficult. The thing is that you have to actually understand the method to solve it. Okay. Now, once you get the understanding or the feeling of the basics, then you are ready to do with any problems. All right. So with this, let's get started on this particular session. And today we're going to be discussing a parabola. So if you like this particular initiative, don't forget to like the video, and if you're new to this particular channel, please don't forget to hit the subscribe button and please click on the bell icon so that you don't miss out any upcoming notification about this JEE Mains revision session. So today our goal is basically to discuss about the conic section part, right? So we are starting with parabola. We will be discussing about the conic section. We'll discuss about the previous year problems. We'll solve both MCQ as well as numerical type problems. We'll try to discuss about the JEE advanced previous year problem as well. And then we'll also try to figure out the paper pattern, right? So with this goal, let's get started with the very first problem over here, right? So I would request all of you, if you have studied or completed the preparation for your parabola, please try this particular problem at least. Okay, so if you just try to solve this problem, you will understand that what is this problem talking about. Okay, so all right, so I hope you are able to see the question. So please give it a try. So I would request all of you to please give it a try. Then we move to the next part, right? So if you have if you read the problem is talking about that there are two parabolas. Okay, so it is talking about two parabolas with the same focus. Okay, so let us try to draw the graph. First of all, let us try to understand the standard parabola, right? So any standard parabola that we can see, let us say that parabola has this vertex as origin 0 comma 0, and it is basically like this with the focus at a comma 0. The standard equation of parabola is basically like y square is equal to 4ax, right? So if this is the standard equation of parabola, and of this particular standard parabola, we have the focus at a comma 0. We have the focus at a comma 0, right? So it is talking about that the two of the parabolas have the same focus, right? So let us try to read the problem and then let us get started on that. So now you please try to understand the way I'm basically solving it. So when I'm reading the problem, I'm simultaneously going on writing the important data that I have in the problem, right? So it is saying that two parabolas. So we have two parabolas, right? Two parabola with with the focus as as 4 comma 3, with the focus as 4 comma 3, and they are directrix. Now what is directrix? So here of this standard parabola, x is equal to minus a is basically called as a directrix. Now why it is called as directrix, you will try to understand. I will tell you later, because there is one of the important property that if you draw any parabola, any two tangent to this parabola, then they are basically at perpendicular to each other. Okay, now that particular intersection point or the locus of the perpendicular bisector of the tangent is basically the directrix. Okay, so this is how the directrix is defined. So if you recall that any general conic section will have a directrix and will have a focus, right? So let us call that this is the directrix of any general parabola, and that is basically given as ax plus by plus c is equal to 0. And let us take up any focus of the conic section as alpha comma beta, right? Now any general point on the conic section x and y can be therefore, so therefore any general equation of the conic section is basically given in terms of eccentricity. Okay, we call E as eccentricity. So eccentricity is basically defined as, so if I draw perpendicular onto this directrix, this is called the directrix. Okay, so for any conic section, I must have a directrix, I must have a focus in order to define it completely, right? So if I draw a perpendicular, and let us call this PM, and this particular distance let us call as PS, right? So eccentricity of any conic section is defined as PS upon PM, right? Now depending on the eccentricity, we will have multiple cases, right? But for the case of parabola, the PS is equal to PM. For parabola, so for parabola, so we have eccentricity equal to 1. So for parabola, the eccentricity is equal to 1, and when the eccentricity is equal to 1, we will have a parabola, right? So therefore, I can from here, I can easily write the any general equation of conics as x minus alpha whole square plus y minus beta whole square is equal to e square times the magnitude of this p from this ax plus by plus cd line. Okay, that is PM length. So PM length will be simply given as ax plus by plus c divided by a square plus b square, now whole square of it, right? So from this particular expression, we can simply calculate or evaluate any general equation of conics, right? Now in this problem it is said that a two parabola has the same focus and their directrix are given as x and y axis respectively. So let us try to draw the situation over here. So if we try to figure out the situation over here, that is, let us say the first parabola is like this. Okay, let us try to draw the first parabola like this, because the first parabola has the directrix as the x-axis. Okay, now okay, wait, let me try to make the, yeah, because it won't have the vertex as the center on the x-axis. So let us put it like this way. All right, so this is a first parabola whose directrix is the y-axis, right? And similarly, let us try to draw one more parabola. Okay, one more parabola like this way, whose directrix is basically the x-axis. So if I try to draw the axis of the parabola, and you know that axis of the parabola, and they are basically having the common focus. So let us call this S as a focus, that is given as 4, 3. Now the diagram is little bit, it might be clumsy, but you please try to do it by yourself as well. You will understand that this is nothing but not very difficult thing. Okay, so let us call this focus as a common focus as 4, 3. Okay, so this particular common focus, now if I try to draw it over here, so I will see that this, let us call this a second parabola, and this one is a first parabola. So this one is a first parabola. Okay, so with this particular information, I have been said that the directrices are the x and y respectively, right? If the parabola intersects, now if the two parabolas are intersecting at point A, which is given as x1 y1, let us call that A is given as x1 y1, and it is also intersecting at B. It is also intersecting at B, which is given as x2 y2, right? So let us say the parabola intersects at A and B, then it to basically find out the distance of AB. Now this question might be difficult at the first time, right? So how to solve this problem? Now let me tell you that for solving this problem, we have to simply use the basics of eccentricity. So for parabola, the eccentricity is equal to 1. So therefore, any distance of any point on the parabola from the focus is equal to the perpendicular distance of the point from the directrix, right? Now our any general point can be A and B. Right, I don't need to solve for this A and B. Let us try to understand that without even solving it, we can also get it, right? So if we try to, first of all, let us try to find out the equation of the parabola first and second, right? So if I try to find the equation of the parabola, so let us try the parabola number 1 and its equation. So parabola 1 equation. Now the equation of parabola, first parabola will be basically given as x minus 4 whole square plus y minus 3 whole square is from the distance of the point from the focus is equals to the distance of the perpendicular distance from point P from the directrix, right? So for the first parabola, the directrix is y-axis, so the distance will be basically equal to x. So it is going to be x square, right? This is my first parabola equation. Second parabola, similarly, the equation will be like x minus 4 whole square plus y minus 3 whole square is equal to y square, because our second parabola directrix is the x-axis. So any distance of a point, perpendicular distance of a point from that on the x-axis is basically going to the y coordinate, right? So it is just by using this particular expression. So here the eccentricity is 1, so I'm just able to write this particular expression, right? So if you just do it, you will get it. Okay, there is nothing difficult over here. All right. So from this, now we just have to solve this first equation and second equation, right? So if you just try to solve, the first equation and the second equation over here, we are basically going to get two roots of x and y, therefore which are basically corresponding to a and point B, right? So from this, if I try to solve it, what we can see that x is equal to y, right? So one of the obvious solution is x equal to y. So if I just put x equal to y in the first equation, I will get a quadratic equation like this: x square minus 14x plus 25 equal to 0. From this, I will get two roots in x. One of the roots is basically going to be, now in spite of solving for the roots, I can directly solve for it because x is equal to y, right? And I need to find out the distance between a and b. So what is ab distance? Ab is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. Right, now you know that x equal to y, so therefore y2 is y2 equal to x2 and y1 is equal to x1. So from here I can simplify this part and write like this: 2 times of x2 minus x1 whole square of it, which I can also simplify right like this: square root 2 times of x2 minus x1. So I just need to find the x2 minus x1, right? So I have a quadratic equation in x satisfying whose roots are basically given as x1 and x2. Now this is a basically way of solving the problem in a smarter way. Okay, instead of solving for x and y, x1 y1 and x2 y2, I am basically solving this in the engineer's approach. Okay, that is basically the smarter way. So I'm not doing many of calculations. You know that engineers are very lazy people. Okay, they don't want to solve calculations. That's why they have invented these mathematical juggleries and all techniques, so that they can easily calculate it instead of doing the summation and multiplication. All right. So from this part, so I can simplify the sum difference of the roots as, so if you have studied quadratic equation, you can simply do this part simply as x2 minus x1 can be written as, can be simply written as, x2 plus x1 whole square minus 4 times of x1 x2, and this should be square, right? So from this part I can simply find out x2 minus x1, which is basically, so x1 plus x2 is equal to 14, right? So 14 square over here minus 4 times of x1 x2 is going to be 25. That is, from here I will get, it is basically equal to 96. So x1 minus x2 is going to be square root of 96. So if I just do it over here, now this part is going to be square root of 192, right? But in the problem, I have to find out AB square, that is distance of AB square. So this is basically AB. So distance of AB square is going to be 192. So distance of AB, is basically going to be equal to 192 units. Okay. So from this, I will get option number D as my correct answer for this particular problem. I hope this problem is clear to all of you. So this problem was all about the basics of building or writing the equation of parabola. And once we get the equation of parabola, from that we have to solve for 2 points. And we are not exactly solving for it, but just we are using the concept of roots. We are using the concept of difference of the roots from the summation of the root and the product of the root, that we have already seen in the chapter of quadratic equation. That is a basics part of your math syllabus, right? So when you come to class 11, they generally start with trigonometry and then move to the quadratic equations, right? So in that quadratic equation, you must have studied this, that whenever you are given a quadratic equation, the sum of the roots, the product of the roots, those things might be clear to all of you, right? So I just use a simple that particular thing over here, right? So instead of calculating x1 and x2 separately, I just use the concept of product of the roots and the summation of the roots to get the answer. All right. So please let me know if this is clear or not. I hope this is clear to all of you. So I was much clear this time, okay, to explain you this particular part. So I hope this is clear to all of you, right? If anything is a confusion point, anything, if you have any doubt, slightest of a doubt, please don't hesitate to ask over here. Okay, you can definitely ask any doubt, any problem that you are facing. Okay, maybe if you're not able to understand the method that I'm used to solve this problem, you can ask me that also. Okay, so I will be very happy to explain you these things, right? So please let me know if you have any questions or not. Otherwise, we shall proceed with the next problem then. All right. So I hope this part is clear to all of you. Okay. So this part is clear to all of you. So I'm checking your live chats. Please let me know if this part is clear or not. All right. So this part was totally about the building of the equations. Just you have to build the parabola equations, and once you're able to build the parabola equation, you have to solve for the parabola equation in order to get the point of intersection. So from that point of intersection, I actually found out the distance between AB. Okay. I hope this is not any confusion anymore. So let us now proceed with the next problem. Okay. So let us proceed to the next problem, right? So the next problem that we have is on the screen. Okay. Please give it a try, then we discuss about it. Okay. So it is also a very interesting problem which discuss about the area, concept of area, right? So if we start reading the problem is basically talking about that I have a parabola, which is a standard parabola, y square is equal to 4ax. So which is basically like this way. Okay. So I have the standard parabola, y square is equal to 4x. Okay. Y square is equal to 4x. Right. So this is the most standard parabola. I will have it over here. Right. So from this parabola, it is said that ABCD is a trapezium which is inside the parabola and whose vertices lies on the parabola. Okay. It is also said that let the sides AB and BC of the trapezium be parallel to the y-axis. So if AB and BC is parallel, so I have to have the sides like this way, parallel to the y-axis. So let us call this point as A, this B, and this C, this D. Then AD and BC is parallel to the y-axis, as you can see over here, right? Therefore, and the vertices are on the parabola, right? Then it is said that be parallel to the y-axis if the length of the diagonal AC, if the length of the diagonal AC, if the length of the diagonal AC be 25 upon 4, be 25 upon 4 units, it passes through the point 1 comma 0. Then it passes to the point, so it has the length, so this diagonal AC passes to the point 1 comma 0, which is basically nothing but the focus. So from here this parabola has the focus as 1 comma 0. Now if a chord passes through the focus, it is a very special chord. Okay, I will tell you about this part. Okay, now, so any chord passing through the focus is a very special chord, and that particular chord, if we know a parametric form of representing the vertices, I know the other point as well. So I don't have to define two different variables. Instead, I can work out with only with one variable, right? So it is said that it is passing through this point focus 1 comma 0, and it is the length. So AC length is basically given as 25 upon 4, right? Now I will tell you this is basically called as a parametric form of parabola. Okay, parametric form of parabola. Okay, so what is the parametric form of parabola? So if I have the quadratic equation or coordinate equation of the Cartesian equation, that is what we call as a Cartesian equation, right? So y square is equal to 4x. So in this Cartesian equation, I can replace this x with, if I replace this x with t square, then I will get y is equal to 2t. As simple as that, right? So therefore, any point on the parabola can be written in terms of t square comma 2t, right? In general, if I talk about in general, because I know the general equation of parabola is given like y square is equal to 4ax, right? So if I put x is equal to 80 square, then I am going to get y is equal to 280. Right. So if I put y square is equal to 4ax, that is the equation. So therefore, any general point on the parabola can be given in terms of 80 square comma 280. That is our any general point on a parabola. Right. Now, if I have any general point of the parabola, and if that point, and if I join that, so let us say that this is a parabola over here, and if I have the point P on the parabola and it is passing through the focus, and let us try to join the chord, let us try to join another point on the parabola such that this particular line PQ is passing through the focus. So our focus is a comma 0. So if this is passing through focus, then if I consider the parameter of P as t, so you can see the parameter of P is basically t, right? Because it defined in terms of t, right? So therefore, the parameter of q should be equal to 1 upon t, right? The parameter of q will be equal to 1 upon t because it is a focal chord. Okay, so if you recall the properties of the focal chord passing the focus, so it will have a very special property, that is, if you are considering one of the parameters as t, the opposite vertices of the focal chord will have the parameter simply as 1 upon t. Okay, so this is basically for focal chord. Okay, focal chord over here. So I will write this as focal chord, and this is basically for the focal chord. Okay, so for the focal chord. So for the focal chord, this particular property exists. Okay. Now we also know one of the important property of a focal chord is that the distance between a focal chord, the distance or the length of focal chord. Okay, the length of the focal chord is simply given as a times of t plus 1 upon t whole square. Okay, now if you just recall this definition from your initial basics of the parabola chapter, then you basically can solve this question very easily, right? So from this part, you can find out point A, B, and C, and once you find the vertices of point A, B, C, you can find the area of the triangle, area of this quadrilateral as 2 times the area of this triangle ADC. So you know how to find out the area of a triangle if you have given with the vertices, then just 2 times or twice it to get to the area of the quadrilateral. That is our simple approach that we're going to use over here, right? So if we try to solve it, so also if you don't even try to do that, also you can find out the simple the trapezoid area as half into sum of the base plus multiplied with the distance with the parallel side, right? Which I can simply do it over here. Now let us try to solve it further. So if I consider, so let us say I consider a point A, as since our small a is basically 1, so therefore let us consider this capital A point as t1 square comma 2t1, okay, comma 2t1, right? That is our A1. So A and C are having at the opposite vertices of the focal chord. So therefore C should be equal to 1 upon t1 square comma 2 by t1, right? Now if we have this information, and from this information I can find out AC length. AC length is given as 25 upon 4, which is nothing but 2 times of, sorry, not 2 times, it 8 times. Our A is basically 1 into 1 over here. So therefore it is basically t plus 1 upon t. So I'm putting t1. So t1 plus 1 upon t1 whole square, right? Which I can simply expand, and I can write this as t1 plus 1 upon t1 is basically going to be nothing but 5 by 2. I can put a plus minus over here. So from this, I will get a quadratic equation, and on solving this quadratic equation, I'll get two roots. One is t1 is equal to 2, and t1 is also basically equal to 1 by 2, which are nothing but the opposite vertices of the focal chord. So our point A, so from this, I will get our point A is basically 1 by 2 comma 1, and our point C, I'll get it as, I'll simply get the point C as, so our point C, please correct me if I'm wrong. I guess this should be 1 by 4, right? 1 by 4 comma uh, 2 times of t, right? That is 1. Yeah, fine. So therefore, this will be basically 4 comma minus of 4. And if we have this information, I can complete d also, as d should be, because it is this is basically perpendicular line AD is parallel to the y-axis. So therefore, it should have the same x coordinate. So it is basically having this x coordinate, and it is basically going up. Now the y coordinate I am not sure about, right? So let us try to first of all complete it, because, and this b is also perpendicular and it is parallel to the y axis, so it's also have the x coordinate as 4, right? Now I have to know about the x coordinate, y coordinate about it, right? Because why do I need to know the y coordinate? But before that, let us understand the distance of parallel lines. The distance between AD and BC are the parallel lines, right? So distance between AD and BD will be simply given out as the difference of the x coordinates of C and A, which is basically 4 minus 1 upon 4, and that is basically given as 15 upon 4, right? And if I need to know what is the sum of, what is the length of this particular sides or the parallel sides, so for this part I need to know the y coordinate, right? Now I know that this point B lies on the parabola y square is equal to 4x. So if I try to put x equal to 4, I'll get y is equal to minus of 4, sorry, plus of 4, right? And similarly, if I know C is basically 4 comma minus of 4, and similarly I know D, that is 1 by 4 comma 1, comma minus of 1, just putting x in the this particular equation of this parabola, and this is going to be 1 upon 4 comma 1, right? So from here I have the all the information. So this particular length is going to be 2 and this particular length is going to be equal to 8. So our area of the trapezoid is basically the area of the trapezium. So trapezium area, so area of the trapezium, okay, ABCD is basically becoming half into this is the parallel side, which is basically nothing but 15 upon 4, and the sum of the parallel side, which is nothing but 10, right? So from this part, you will get the solution as 75 upon 4 square units. Okay, so that is going to be the area of the trapezoid. So the trapezium area is basically option number D, which is basically 75 upon 4 square units. I hope this is clear to all of you. I hope this is clear to all of you. Please let me know in the comments or the live chat if this is clear or not. This part is pretty straightforward, right? Okay, so I'm going through your live chats. Please let me know if you have any queries or if you have any questions. You can definitely ask me in the comments or the live chat. Okay, so this question was fair enough, right? Very straightforward problem, right? So let's now proceed with the next problem then. I hope you have understood this problem. So if you have any confusion, you can definitely ask me. If you don't have any confusion, we can proceed to the next problem. I hope this problem was straightforward to all of you, right? You just have to remember the properties regarding focal chord, right? So if you just know how to parameterize any point on a parabola, then you can definitely find the coordinates of it, right? So just by putting the coordinates in the equations and for solving for t, right? So once you solve for t, you get all the informations because you have the information about the equation of the parabola, right? So this part is clear to all of you. I hope this part is clear. So let us move to the next problem, and next problem is really an interesting problem. Now in this problem, it is talking about that particular information that I have discussed in the basics, that is you have to understand the eccentricity and the of the parabola, right? So if you know this particular part, then only you are going to solve it very easily. Okay, so let us recall. So what I said, that PS is equal to PM, right? Because I am having eccentricity is equal to 1, so for parabola this particular condition will hold true, right? So it is said that I have to find the equation of parabola whose vertex. Now, what is the vertex of the parabola? It is basically given as 3 by 2 comma 3, right? So vertex is nothing but the intersection of the parabola with the axis. Okay. So what is axis? Axis is a line which is perpendicular to the directrix. Okay. So if this is the directrix, and if I draw a perpendicular line to the directrix, and that is the axis, so wherever this parabola is symmetric, okay, and now you can see that the parabola is symmetric about it, right? And also this particular directrix, this particular axis will also pass to the point where this particular part is symmetric about, right? Okay, so you can just see from here, right? Now if you just recall, so it is said that the vertex is given as 3 by 2 comma 3, and the directrix is simply given as directrix is given as right, the directrix is given as x plus 2y is equal to 0. The directrix is given as x plus 2y equal to 0, right? So from that I have to find out the equation of the parabola, right? So if I recall from this particular problem, so if you just recall from the simple definition of your parabola, so your equation of axis is going to be passing the vertex and it is perpendicular to the directrix. So what is the slope of the directrix? So slope of the directrix, so slope of the directrix is going to be minus of 1 upon 2. Therefore, the slope of the axis should be equal to 2, right? Because we know that the axis and the directrix are perpendicular to each other. So from this, I can find out the equation of the axis is basically y minus 3 is equal to 2 times of x minus 3 by 2, right? So from this, I'll get the equation of axis as y minus 2x is equal to 0, right? So this is my equation of my axis, and let us call this equation number 1, right? Now it is said that now if I try to find out the foot of the directrix, let us try to find out the foot of the directrix. Okay, so so from this particular problem, if I have the directrix and if I have the equation axis, so the foot of the directrix is basically nothing but the point where this axis and the directrix are intersecting. This is called the foot of the directrix, right? So if you just solve for this y minus 2x equal to 0 and x plus y is equal 2y is equal to 0, so you will find out that your x and y, this particular point is both coming out as 0 comma 0, right? So your foot of the directrix, oh sorry, very sorry, right? So yeah, so let us extremely sorry. So we were basically discussing this problem like this way, right? So our equation of the axis basically y minus 2x is equal to 0. That was our equation of axis, right? And our directrix was x plus 2y is equal to 0. So this particular point, the foot of the directrix, okay, is basically coming out as 0 comma 0. You can solve for these two equation, right? Now if we have this information, if we have the foot of the directrix, now if I have the vertex over here, so let us call this is a vertex that is basically given as 3 by 2 comma 3, right? And I have the any general point. So if I take now our important task is basically to find out the focus. I know that the focus will always lie on the axis and it will have the same distance. So if this particular distance is basically what? It is the distance of the A, and that is the same distance that the focus is also from the vertex, right? So let us call this S as a focus. So S is the focus. So that particular distance is also equal to AA. So VS is also equal to A, right? So from this part, I can simply find out. So this particular S will lie on the axis. So therefore, and this particular distance should be equal to A, right? So let us try to find out. So this particular distance A is going to be equal to. So this particular distance A is equal to. So I can simply find out the distance as 3 square plus 3 by 2 whole square and square root of that, right? So which is simply coming out as, so you can solve for it, is coming out as 9 plus 9 upon 4 square root of that, right? So with this part you will get it as 36 plus 4, that is going to be 45 upon 4, square root of 45 upon 4, right? That is going to be my distance A, right? Now I need to have the same distance of A such that to get the focus over here, right? And focus will lie on the axis y is equal to 2x, right? So from this part, I can simply calculate, and giving the distance A as 40 square root of 41 and 4, so this focus will be coming out as 3 comma 6. You can calculate for that, okay? So from this part, I'll get the focus as 3 comma 6. Now, if I have the focus, I know the directrix, so I can find out any general equation of a parabola in terms that this PH distance should be equal to this PM distance, right? So the general equation of parabola, so our equation of parabola is will be coming out as x minus 3 whole square plus y minus 6 whole square should be equal to the distance of the point P from the directrix, that is x plus 2y divided by square root of 5. Oh, very sorry, I must have written it a square plus b square. Yeah, you should put it square root of that. Okay, this is a square root over here. Okay, please excuse me for that. Okay, maybe I was writing square over it, so I forgot. Okay, all right, so please correct it. This is a correction over here, please correct it. Okay, so this should be square root of 5, right? And we should take a square of that, right? So from this part, you will, if you solve for this, you will get the general equation of the parabola in terms of 4x square plus y square minus 4xy 4xy minus 30x minus 60y plus 225 should be equal to 0. Now, if you just compare with this equation and the given equation that is mentioned over here, you will get alpha is equal to 4, you will get beta is equal to 1, and you will get gamma is equal to 4, right? So you will have this particular information, and this information is given to you. You have to just simply find out the value of alpha plus beta plus gamma, which is nothing but option number D, that is 9. So from this particular problem, you can see that this problem is basically on the question of building the equation of parabola. Very straightforward problem, right? Now, if you look in general, the question that are basically asked in JEE Mains for the chapter of parabola, it is generally from the part of equation of tangent, equation of normal, or it will be from the part of the chords of the focal chord and the basic part where you are building the equation of the parabola. Now, those are the four important parts from where generally the questions are basically being asked. I hope this is clear to all of you. Okay, if this is not clear, you can definitely let me know in the comments or the live chats. I am basically going through a live chat. Okay, please let me know if you have any questions. I hope this is clear to all of you, right? So there is not an issue anymore over here, right? So if you have any questions, you can definitely ask me up. Okay, I'll be helping out with your queries. Okay, and even if you're watching the lecture as an offline lecture, or if you're watching after the lecture is over or the session is over, you can still ask me the questions in the comment section. Okay, I'll be looking forward for your comments. All right, so please let me know if this is clear or not. Fine. So I hope this part is clear to all of you. So from this part, you will get the value of alpha, beta, and gamma easily. And you know that how do you find out? You just use a simple equation of parabola by the simple definition of the eccentricity concept, right? And if you have still any confusion that how did you find the equation of the axis, so from the directrix, we know the axis is perpendicular to each other. So from that, I can simply calculate for that, right? And we have the vertex information. So axis will pass through the vertex and it is perpendicular to the directrix. So if you have one point and the slope of the straight line, we can simply find out the equation of the axis. I hope this part is clear to all of you. Please let me know in the comments if this is not clear. So if you have started watching this session for the first time, don't forget to hit the like button, okay? And please make sure that you subscribe to the particular channel, okay, and help us support the mission that we are basically on it, okay. So if you find these lectures very helpful, please don't forget to share it with your friends as well, right? So if you share it with your friends, maybe someone who is not very fortunate to get the tuition classes, they can definitely take the help of these live classes, and which are basically just for free, okay, and definitely get their doubts cleared from me, okay. So this is a free initiative that taken by me and my team. Okay, so you can just see over here that we are basically discussing all the parts of the chapters, and we are basically working on that part. Okay, so with this part, I hope you will understand the motive behind it, and you will help and you will benefit your preparation from these particular sessions. I hope this revision is going to be really important for you, all of you. Okay, please let us help also in reaching our mission to all of us, okay, like all of the needy persons who are basically starting out for the preparation and they need it, okay. So don't forget to share it with your friends, okay, so that they also get this chance to study from me. All right, so I hope this part is clear to all of you. Please let me know in the comments anything if you have any doubt. All right, so let us proceed further. If you have no queries, we can then straightforward proceed with the next problems, okay. So the next problem we have with us is basically another very interesting problem. Now this problem basically includes a parabola and a circle, and mark my words very clearly that this is basically very important problem, okay. Please star mark this problem as important, okay. Now these types of problems are mostly repeated in every JEE mains, okay. So you can just take this problem as a basically a simple mug up type of problem, okay. So please make sure that you revise these problems very nicely for your exam, okay. So it is said that let the shortest distance from a point a comma 0 to the parabola be 4. So the parabola is given as a general or the standard parabola, that is y square is equal to 4ax, or the 4x where a is basically 1, okay. So it is a standard parabola, that is 4x, right? Now it is said that the distance of the point a comma 0, so a comma 0, let a comma 0 is any point on the x-axis, so that is basically an a set positive, so therefore distance of parabola, this particular point to the parabola, now you know this is shortest distance, so it must be along the common normal, it must be along the normal, right? So it should be normal to this particular parabola. So let us call this point as some point q, so this pq should be the normal to the parabola, right? Now here we are going to use the concept of normal to the parabola, right? So let us try to revise quickly the normal or the equation of normal for a parabola, right? So if we are having any standard equation of parabola like this way, right? Y square is equal to 4ax. This is a standard equation of parabola. So at any point P, and that particular point P in parametric form is given as 280, comma 280 square, 80 square, comma 280, right? That is the standard parametric form of the point on a parabola. Now, if we have this standard parametric form, now I can just simply take the derivative of this parabola at that particular point P, and I will get it basically equal to 2a by y, right? And if you just put it, you'll find out that the slope of the slope of the tangent is basically becoming minus of 1 upon t, okay. So sorry, plus of 1 upon t, right? Plus of 1 upon t, right? So if you just put it, you will find out that the slope of the tangent, now this is basically nothing but it basically dy by dx is nothing but the slope of the tangent, right? Slope of the tangent. Now from this, slope of the normal is nothing but it is going to be minus of t. So if you have this information about the slope of the tangent normal, so you can know that the equation of the tangent normal, equation of normal, equation of normal through this point P is simply given as y is equal to minus xt plus 2t plus plus ATQ. Okay, now put it A over here because we are writing for the general case, right? So any general equation for normal passing to the point P, which is basically 80 square comma 280, it is basically given as y is equal to minus xt plus 280 plus ATQ. For this particular case, we have our A for small a is basically 1. So I can write the equation of the normal. So our parabola is basically y square is equal to 4x. So let us consider any point is basically given as t square comma 2t, right? So the equation of a equation of normal normal through P will be given as y plus xt is equal to 2t plus tq is equal to 2t plus tq, right? Now it is basically it has the point a comma 0, right? Because we are basically trying to find out the shortest distance of it, right? So our q point basically lies in the normal common normal. So this is basically, so I just need to satisfy a comma 0 into this equation to get out the value of t. Okay, so from this particular I'll get a I'll get this over here as AT is equals to 2t plus t cube, right? So from this, one of the obvious solutions t is equal to 0, right? And I will also get, so our A is basically I will get it as, so I will get A as 2 plus t square, right? So I will get this point q as 2 plus t square comma 0, right? 2 plus t square comma 0, right? Now if I have this point, I have to find out the distance of PQ. Now I know the shortest distance is basically given as 4 units. This particular shortest distance is given as 4 units. So our PQ distance is going to be is equal to 4 units. So which I can find out simply as 4 plus 40 square, right? 4 plus 40 square, which is basically given as 16. I just take the square of it, okay? The square of it will be basically produce this particular expression, okay? You can do it by yourself as well. All right. So it will basically give you this result. So from this, you can simply find out that 40 square is equal to 12. So you will t square. So your t square is basically equal to 3. So you got the value of t square as equal to 3, right? Now it is said that then the equation of the circle passing to the point a comma 0 and the focus of the parabola. So focus of the parabola is nothing but 1 comma 0. So the focus is 1 comma 0 over here. So you have to find out the circle whose passing the point a comma 0 and 1 comma 0 having its center on the axis of the parabola, right? So from this particular part, so if it is having its axis on the center of the having its center also on the parabola, so it is basically like this, is passing to this particular point a comma 0 and passing the focus like this, right? Okay, and center is on the axis, so therefore this is going to be the end points of the diameter or the diameter endpoint, right? So from this part, if I have the value of t square, I can find out a is basically nothing but a is basically going to be equal to 5. So our point q is going to be 5 comma 0. So and s is basically 1 comma 0. So these are the two diametrically opposite point of the circle. So our circle is basically like this, whose diametrically opposite point with the center c and the diameter opposite point is basically 5 comma 0 and 1 comma 0. So for this circle, I can simply write the equation of the circle from the diameter form, that is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So from this, I will get the equation of the circle as x minus 1 into x minus 5 plus y square is equal to 0, which is basically nothing but x square plus y square, x square plus y square minus 6s plus 5 is equal to 0, which is going to be required equation of the circle. I hope this is clear to all of you. So with this, you will see that option number B is going to be my correct answer. So option B is going to be my correct answer for this particular problem. I hope this part is clear to all of you. Please let me know. Please let me know this clear or not. This was very straightforward. Yeah, hi Fortrex Gamer. Foxstar Gamer. Okay, sorry for the pronunciation. Foxstar Gamer. Alright. So I hope you are able to understand this part. All right, so this was a very similar problem. We are basically using the equation of the normal and we are basically simply putting it, and we know that shortest distance always occur along the common normal. Now you can please write it also over here, that shortest distance will occur along common normal. Now here we have a point, so therefore the common normal will pass to that particular point only. But if you have two curves like a circle and a parabola, then that must be passing to the common normal. The shortest distance will always occur along the common normal. Okay, so shortest distance will always occur along the common normal. if you can write it down, it is very, very crucial. Okay, this is very, very important. Now with this particular part, you can see that many of a JEE advanced problem is also going to be solved over here. So I'm putting a star mark over here. Please make sure that you don't forget it. Okay, so this is very important and crucial. So common solutions will always occur along the common normal. All right. So please let me know if you have any questions. Otherwise, we can proceed. Please let me know if you have any questions or not. Right. So this part is clear to all of you. This part is clear to all of you. I hope this part is clear to all of you, right? Very straightforward problem. So with this part, let's move to the next problem. The next problem we'll be talking about if a line. Now it is basically the question about we have to basically find the angle a line segment pursues or makes with the given x and one particular side, right? So this is what you have to do over here. So if you just look at the problem, it is saying that if the line 3x minus 2y plus 12 intersects the parabola. Now our parabola over here is basically, instead of giving the standard parabola, it is given as x square. X square is basically equals to, sorry, x square is basically given as 4 upon 3y. Okay, our x square, our general parabola is basically given as y square is equal to 4x, but here we are basically given as x square. X square is basically coming out as, we are having x square as 4 by 3y. Okay, so this particular parabola will be like upward opening parabola like this way. Okay, now for this particular parabola, I will have this focus at sorry 0 comma 1 by 3. I'll have the focus at 0 comma 1 by 3, right? Okay, so if I have this information of the focus, okay, now it is said that there is a line which intersects this particular parabola at 2 points. Let us call this first point as A and this point as B, and this particular line equation is given as 3x minus 12y plus 12 is equal to 0, right? This is our line equation. So if I just need to solve it with this particular parabola and the line, so let us try to do that. So if I just try to simply substitute y is equal to 3x plus 12 divided by 2 and put it back into this particular equation, I will get a quadratic equation x. So that quadratic equation x will be like this. So that is 3x plus of 12 divided by 2 into 4 upon 3 is equals to x squared. So from this I will get a quadratic equation in x, that is x squared minus 2x minus 8 is equal to 0. I hope this is clear. So from this, you will get two roots in x which correspond to the point A and point B, right? So let us try to find out our two roots. Our x1 is basically going to be minus of 2 and our x2 is going to be 8, right? So it's going to be 4, sorry, extremely sorry. So this is going to be equal to 4. This is going to be equal to 4. So from what you can see that our point A, x coordinate is basically nothing but it is basically minus 2 comma, and if you put minus 2 in the x-axis, so x is equal to minus 2 and you get the y. So you get y as 3. You get y as 3. So our A coordinate is minus 2 comma 3, and similarly B coordinate is going to be 4 comma. Now if you put x equal to 4, our y is coming out as 12. Okay, so your B coordinate is going to be 4 comma 12. 4 comma 12, right? So if you have these two equations, now you have the equation about the vertex is about the A and B, right? Now it is said that then the vertex of the parabola, so vertex is basically this particular point, that is 0 comma 0, the vertex of the parabola, then at the vertex of the parabola, the line segment AB subtends an angle. So I have to just put it, I have to draw a straight line joining this vertex with the A and B's, right? So which is very simple. So I need to find out the angle between the line. So if you just recall that angle between any two lines with a given slope m1 and m2, this particular angle is simply given out as, is simply given tan inverse of mod of m1 minus m2 divided by 1 plus m1 m2, right? So if I just put the values of, so m1 is basically nothing but AB line, right? AV line, and m2 is basically VB line. Okay, so this particular slope I can simplify it out, and from there I can simplify the angle theta as tan inverse of, now my first slope is going to be minus of 3 by 2 minus 3, and the second slope is going to be 3, right? So that is it. I will get it as over here as 1 minus 9 by 2, and let us put a mod over here. So we'll get this particular expression as tan inverse of 9 upon 7. So our theta is, that is the angle that the AB chord subtend at the vertex, that is nothing but tan inverse of 9 upon 7, and that is going to be an acute angle. Okay, so I'm just putting a mod over here and to get the acute angle, so I will get it option number B as the correct answer from this particular scenario. I hope this part is clear to all of you. Please let me know if this is not clear. if anything is not clear, you can definitely ask me in the comments. Okay, so this part is straightforward. Okay, this part is very straightforward. All right, so please let me know if you have any questions. All right, so these were all about the top important parabola questions that I need to discuss in this today's session. So I hope you got some idea about what are the different sets of problems that you're going to definitely expect in the exam. That is, first of all, basis of the equation of the parabola. Second, all the important points on the parabola, and then chords, the chord length, those points are also important. Latus rectum, focal chord, those are important. Similarly, the properties regarding chords are important, and lastly, tangents and normal are also very important. So in this session, we saw one question that was of common normal. So for that, you need to know the normal, right? And we need to also know about the any properties of the parabola, right? That is, if you throw a light, if you put a light source at the focus of the parabola, then it will reflect and again pass through the focus itself. Okay, and that is a very important property that is basically used or applied for physics also. And now you will see the physics, most mirrors are basically, to make a perfect mirror, we are basically making it as a parabolic mirror instead of making a circular or semicircular. Okay, so generally we people try to make it a parabolic mirror. Okay, so parabolic mirror, what you will see in the chapter of the ray optics. Okay, that you will see that if you are not making parabolic mirror, otherwise you will have a separated focus. Okay, that the point of the image at the focus is not going to be very clear, it will be blurred. That we will understand in the chapter of ray optics. Okay, so from that particular idea, these questions are very important. That is, if you take a light source and keep it at the focus and you reflect it with the parabola, then it is definitely going to pass through the reflected line is going to pass through the focus itself. Now that is a very important property that is basically applied everywhere. So if you just draw parallel line to the x-axis and you hit the parabola, then it will definitely pass after reflection. It will pass to the focus itself. It will pass to the focus itself. That is the very important and very generic point of the or property of a parabolic mirror and parabola. That's why we are making use of the parabolic mirror. Now students who are basically asking that what is the application of maths, now this is what the application of maths, right? So student, without this definition of the parabola, without understanding the properties of the parabola, we cannot understand that whether if we draw a line parallel to the x-axis and reflect it, will it pass to the focus or not. Then we use the same principle in the physics to develop our parabolic mirror. Now that is all what I have to talk about in this session. So with this, let us end our session over here. I hope you have got something of it and I wish you all the best.